Hello, a very warm welcome to another ARIS Components video from Germany. Today I have a very interesting guest. It is Mr. Kringer from the University of Munich, and he is really taking part in the big progress in space technology. And I think it's best if he introduces himself.
Thank you. My name is Michael Klinger. I'm the team leader and the responsible person for the electronic module in the student team AIMIS Flyothesis. At the moment, I'm doing my master's degree in applied research in engineering sciences at the Munich University of Applied Sciences.
And the purpose of the team was just to do this experiment. Am I right?
Yes, you are quite right. We got inspired from our professor in spacecraft design to do this experiments. And as a part of our aerospace bachelor's program, he offered project works on the additive manufacturing of space components as a method to make the bottleneck of rocket transportation more efficient. And this is how we came to the idea of our additive manufacturing process, which we were currently investigating. Our research focuses on the manufacturing of satellite components, such as truss structures, for example, for solar modules or antennas, which should be produced directly in space. The advantage should be that satellite components are designed according to the highest forces that occur. These forces usually occur only during the launch of the rocket. The forces that occur in the orbit are usually very small, since the environment and weightlessness is surrounding it. And that's why satellite parts often very oversized for their operational lifetime.
Well, this is really interesting. And where do the experiments take place? Will they be on the ISS or in special flights?
The experiments take place in parabolic flights. We have applied for the Flyothesis program of the European Aerospace Agency. And with the Flyothesis program, you get the possibility to do experiments under microgravity conditions. The platform for that is an Airbus A310, which flies 93 parabolas with us and our experiments. During each parabola, we have 22 seconds of microgravity.
Wow. And what was the specific requirement regarding the components you used?
It's particularly important to us that the components are reliable. We have now been working intensively on the experiments for over a year. It would be a pity if the experiments failed in flight due to the fail of a component.
And how would you rate the collaboration with ARIS Components, especially in the times of COVID-19?
Well, COVID-19 was, of course, a very challenging situation for us during the lockdown. We could use our laboratory only with restrictions. For example, only 2 team members were allowed to enter the laboratory at the same time. We were also concerned that there would be bottlenecks and delays in our orders, but ARIS Components fortunately provided us with all the components very quickly and very uncomplicated. That was a really big help for us and the project. Thank you for that.
Oh, it was really, really a pleasure for us, because that's our understanding, that we bring ideas into life and that we help people who are inspired to push technology forward. Yeah. And so all I can say is thank you so very much and lots of success for your experiment. We will watch you on TV, I hope, and perhaps we see you next on the ISS. Yeah.
Thank you very much.
Thank you.